This is section 9.4b, and it's more about factoring trinomials when it's ax squared plus bx plus c. We're also going to add in equations this time. So you'll remember that we always are going to have a number in front of that x squared term, and that we've always got to get them into this order before we factor them. So I also want to review again that the directions in the rest of this chapter, some of the problems say to factor, and some of the problems will say to solve. And you really got to read those directions, make sure you know what you're doing. If it just says to factor, your answer will be parentheses with binomials in them. If it says to solve, then your problems have an equal sign, and you're setting it equal to 0, and you're going all the way to the end where you solve and you put your answer in braces. So just remember to keep that in mind all the time. So we're going to do some solving problems. The first one we're going to do is 3x squared plus 11x plus 6 equals 0. And the problem does say solve, and there is an equal sign. So the first thing you want to do, you're going to follow the steps of the equations. Step 1, set it equal to 0, is already done. Step 2 is to factor. And the first type of factoring you'll always try is GCF. So looking at the 3, the 11, and the 6, there is no GCF. So I'm going to factor a trinomial. And this trinomial is ax squared because there's a number in front of the x squared. So I will be doing product and sum by multiplying those together. So I need two numbers whose product is 18 and whose sum is 11. So pretty quickly you'll see this one is 19 times 2. So I rewrite this into, instead of 3 terms, it'll be 4 terms. 3x squared plus 9x plus 3x plus 6 equals 0. So I just don't want to forget that each time it's going to be set equal to 0 in this problem. Now I'm going to group them and factor out the GCF of each group. So that would be 3x times x plus 3 plus 3 times x. Oh, I'm sorry, this is a 2. So I am factoring out a 2 right here, plus 2 times x plus 3 equals 0. I'm going to erase over here now. Okay, so I'm going to finish factoring by taking what's outside here and putting that in its own parentheses, 3x plus 2. Take the other one that repeats, make sure that that's the same, x plus 3 equals 0. Now that was all factoring, and I'm up to step 3 where I separate into two different equations. 3x plus 2 equals 0, x plus 3 equals 0. Solve each equation. 3x equals negative 2, x equals negative 2/3, minus 3, x equals negative 3, and you'll go all the way to putting the answer in braces, negative 2/3 and negative 3. Okay, we're going to do another one that's very similar, so hopefully you can do it. You could even try it on your own, but it's going to have a couple more steps. Again, it's going to say solve. The original problem, 8a squared minus 9a minus 5 equals 4 minus 3a. And it says solve, so my first step is to get it set equal to 0. So I see that on the right-hand side here, I've got two things I need to get rid of. First, I subtract 4. And of course, I'm subtracting it from the 5. 8a squared minus 9a minus 9 equals negative 3a. and then I'm going to add the 3a, and I'm going to add it to the 9a. So you're matching it up with its like term. Then I have 8a squared minus 6a minus 9 equals 0. I'm ready to factor on step 2. So I have 8 times negative 9. So my product is negative 72, and my sum is negative 6. So the two numbers are going to be, did I make a mistake here? Oh, I did make a mistake. No, I didn't. No, it's all good. So the two numbers are going to be 12 times 6, I believe. 12 times 6. And I'm going to have a negative 12 and a positive 6. So I'm going to rewrite this term with these two. So I have 8a squared minus 12a plus 6a minus 9 equals 0. Now I'm on step 3, where I'm going to I'm in the middle of factoring right now. I'm going to do the grouping, and I'm going to factor out of the first group a 4a times 2a minus 3. Second group, I'm factoring out plus, plus 3 times 2a minus 3. You know you factored it right if these are the same. Next step, take out what's on the outside of the parentheses, put it in its own. Take what's on the inside of the parentheses, the one that's you see twice and put it once, equals 0. Next step, divide it up into 2. 4a plus 3 equals 0. 2a minus 3 equals 0. And now I'm solving each part. 4a equals negative 3, divide by 4, and we're going to have negative 3/4. Add 3 on this side. 2a equals 3, divide by 2, and we have 3/2. So my two answers, negative 3/4 and 3/2. Okay. Okay, so now that you know how to do these types of equations, now we're going to do a word problem, which I'm going to introduce to you now in this video. We will do more in class because they're difficult. They take some time to figure out, but you will get it. So this comes from your book. This is, page 499 in your book. It says, there's a rectangle here. It says a rectangle with an area of 35 square inches is formed by cutting off strips of equal width from a rectangular piece of paper. So let me explain what that means. They're saying we have this rectangular piece of paper, and according to the picture, that rectangle was 7 inches by 9 inches, and we're taking it and cutting off a trim all the way around the edge. And we don't know how wide that trim is, but that's what we're going to figure out. So we're cutting off a piece here, and the same width here, and the same width here, and the same width there. And we're getting a new triangle in the middle, a new rectangle in the middle, that's going to have an area of 35 square inches. So it's really easy to guess at the dimensions of the new rectangle that's in the middle. If it has an area of 35, then you're probably going to guess 5 times 7 equals 35, so the new one will have a 5 inch by 7 inch, which is going to be right, but none of that's going to, you're going to have to do the algebra for this problem to earn any credit. You're going to come up with an equation and show how to solve the equation to get credit. So, and also they're going to want to know in this problem this x, how wide is this strip that we're cutting off? So, to do it, it starts with the assumption that you know that the area is going to be equal to the length times the width. Now, we need to represent the length and the width using algebraic expressions. Algebraic expressions. And this is how we do it. So we know that this is x, this width, and it's same thing here, x. And it's x here and x here, and all the way around it is x. So I'm going to represent the smaller rectangle with these algebraic expressions, starting with the length of the smaller rectangle. Let me just put this here. So it started out that the whole, oh, let's use this one for the length, sorry. This whole, I usually say the longer one is the length. Doesn't really matter, but normally the longer length, the longer measurement is the length. So it starts out being 9, and we cut off this little edge right here, and that edge is x. And we cut off the edge from the bottom too, and that edge is x. So now I want to represent this line, the smaller line of the smaller rectangle. And the way I represent that with algebra is to say it was 9, the blue one was 9, but then I took away x and I took away another x to get the black line. So I had 9 and I subtracted 2x. That's how we represent the length of that inside rectangle. Likewise, the width, well, it starts out with this line, which is 7. Starts out by being 7. And again, we're cutting away this strip, which is x, and this piece here, which is x. And when we cut that away, we're going to end up with this new one, the smaller rectangle that I'm putting in black. So that to get that length of the smaller one, it was 7, and I've taken away an x on one side and an x on the other side, so minus 2x. So now I've got the length and the width of the smaller rectangle, and I know that the area, they tell me, of that smaller one was 35. So I'm going to set up this equation with all of this information. So that 9 minus 2x, so what I'm doing is saying the length times the width equals the area. The length was 9 minus 2x, the width is 7 minus 2x, and the area of that smaller rectangle is 35. So I'm using this to represent the length, the width, and multiplying them together to get the area. Now this is an equation like I showed you earlier, where we're going to be able to solve it and figure out what x equals. In order to start this one, which we haven't seen before, we haven't had it like this where we have parentheses on the left and a number on the right. So we have to start by foiling these two binomials on the left. So to FOIL, I'm going to go 9 times 7, 63. 9 times negative 2x. Okay, so it was a 4, and then it was x minus 7 times x minus 1 equals 0. So I'm at the point where I have to divide this up, where parentheses are. And this one actually divides into 3 different things. The first one, 4 equals 0. The next one, x minus 7 equals 0. The last one, x minus 1 equals 0. The first one, 4 equals 0, really doesn't make any sense. 4 doesn't equal 0, so we cross this one out. The second one we have to solve by adding 7, and we get x equals 7. Third one, we solve and get x equals 1. Now, we have these two answers, and we have to look at them and see which one actually makes sense. So we go back to our original picture, which had a big rectangle, which was 7 by 9, and then it has a smaller rectangle. The smaller one had the areas 35, and x represented this width, and it's the same, that width, all would be x. So if this whole width right here is 7, then this little tiny spot right here, x, could not be 7. So this answer, because it doesn't make any sense, you cross it out. So that means this one has to be the one that works. So x does equal 1. And now we have to go back and figure out what is the length and the width of our smaller rectangle, the one in here. So we represented it with 9 minus 2x. That's how the algebraic expression. Now we know that x equals 1, so we'll fit that in here. 9 minus 2 times 1 is 9 minus 2. So the length is 2. And this problem, I believe it was dealing in inches. So 2 inches. The width was 7 minus 2x. So that would be 7 minus 2 times 1. 7 minus 2. Oops, sorry about that. This one was supposed to be 7. And the width is 7 minus 2, or 5. The length was 7, the width is 5 inches, which we pretty much guessed from the start, but all of this algebra has to be written out carefully, neatly, with every step involved.